So students, in this video I am going to discuss some extra problems regarding the chain rule. So these are some sort of mixed type of problems. All the chain rules that you have discussed can be applied depending upon the problem. So these are some practice problems. There are so many problems other than this available in the literature. So you can using these sample examples you can study those problems or work out those problems on your own, so that you will be thorough with these chain rules. Otherwise you cannot recall these chain rules as a whole, because some 6 or 7 chain rules I have mentioned in the previous videos. So in order to recall that, you have to constantly practice these sort of problems, and I will be discussing only some sample problems here. Rest it is left to you. You have to work it out from your home. Now come to the first one. These are all mixed problems. Different chain rules depending upon the problem have to be applied. Okay, so the first problem is u equal to x cube plus y cube, given x equal to a cos t, y equal to b sin t. Find du by dt. From the question itself it is clear that we have to find what the total derivative. Now in such problems you first look at the structure of the given function. The given function is u equal to x cube plus y cube, that depends on x and y. Now x equal to a cos t, x depends on the single variable t, y equal to b sin t, y also depends on the single variable t. So the diagram becomes u x y, u is a function of x and y are functions of the single variable t. So in effect the function u has only one variable t, even though it is expressed in the form of with the help of x and y. So that is why we have to find the total derivative du by dt. So we know that in this case du by dt is given by the formula. This is the first chain rule. Du by dt equal to dou u by dou x into dx by dt plus dou u by dou y into dy by dt, dou u by dou x into dx by dt. Dx by dt means because x has only one variable, plus dou u by dou y into dy by dt. Y also has a single variable. Now you just substitute these values from the given problem. That's all. You will get the answer directly. Now dou u by dou x, this is our u. Dou u by dou x is 3x square, the differential of x cube, that is 3x square, into dx by dt. Dx by dt, x is a cos t, its differential is minus a sin t. So 3x square into minus a sin t plus dou u by dou y. Dou u by dou y is 3y square. Y cube, the differential of y cube is 3y square. 3y square into dy by dt. Y is b sin t, so dy by dt is b cos t. Now this becomes 3a square cos square t. I am substituting for x. 3a square cos square t into minus a sin t plus 3b square sin square t. Y is b sin t, so this y square becomes 3b square sin square t into b cos t. On simplifying, you will get the answer as 3 into b cube sin square t cos t minus cos square t sin t. So this is our du by dt. Now if you are given a point, say t equal to 0, in that point also you can find du by dt. For example, if I have to find du by dt at t equal to 0, it is obtained by simply substituting t equal to 0 in this expression. When t equal to 0 in this expression, you get sin square t, sin square 0 is 0, this term becomes 0. Again here also sin t is there, so t sin t equal to 0, this whole term becomes 0, and hence du by dt at t equal to 0 is 0 itself. So if t equal to pi, again you can find the answer. If t is some other angle, you can find again the answer by substituting the value of t. Also, since this is a single variable, u contains a single variable t, you can directly substitute this quantity in this one. Putting x equal to a cos t, y equal to b sin t in this expression, you get a complete expression of u in terms of t alone, and you can differentiate totally as usual, as the previous first differentiation in the case of single variable. You can differentiate with respect to t and you will get the same answer itself. It can be verified. You can do it yourself. Now I am going to the second problem. this is the second problem. Let h equal to f of y minus z, z minus x, and x minus y. H is a function of y minus z, z minus x, x minus y. Verify whether hx plus hy plus hz equal to 0. That is dou h by dou x plus dou h by dou y plus dou h by dou z equal to 0. You are given h equal to f of y minus z, z minus x, and x minus y. So it is evident that you have to apply the chain rule. So in order to apply the chain rule, we have to find the scheme or which chain rule we have to apply. Now here I am converting the given problem so that the chain rule can be, or the structure can be further understood clearly. So what I am doing is I am putting y minus z equal to u, z minus x equal to v, and x minus y equal to w. So what happens is h becomes a function of u, v, w. H becomes a function of u, v, w, where u equal to y minus z, v equal to z minus x, and w equal to x minus y. So in this way, it will become more convenient to apply the chain rule. Or if we are not choosing u, v, and w, we will be confused which chain rule is to be applied. So that is why I am substituting this in the given manner, that is h equal to f of u, v, w, where u equal to y minus z, v equal to z minus x, w equal to x minus y. Now you can see the structure as below. H is a function of u, v, and w. H depends on u, v, and w, and u, v, w, all the three functions depends on another three variables x, y, and z. You can verify. U depends on y and z, v depends on z and x, even y, w depends on x, y, and z. So the structure is like this. H depends on u, v, w. You will find h in terms of u, v, w, and u, v, w are in turn functions of x, y, and z. So you will have in effect three variables in h, that is x, y, and z. H contains three variables x, y, and z. So in effect we have to find out three partial derivatives, that is hx, hy, and hz. Now hx equal to dou h by dou x. Hx equal to dou h by dou x. You can write the differential chain rule from this figure. Dou h by dou x equal to dou h by dou u into dou u by dou x plus dou h by dou v into dou v by dou x plus dou h by dou w into dou w by dou x. So that is what I have written here. Dou h by dou u into dou u by dou x plus dou h by dou v into dou v by dou x plus dou h by w into dou w by dou x. Now substituting for these values, dou h by dou u, we don't know what is this one. So I am writing dou h by dou u as such. So dou h by dou u into dou u by dou x, this we can find from this expression. Dou u by dou x, u contain no terms involving x. So dou u by dou x equal to 0. So dou h by dou u into 0 plus dou h by dou v into dou v by dou x. Again, we don't know what is dou h by dou v, but you know dou v by dou x. Dou v by dou x is minus 1. V is z minus x. So dou v by dou x is minus 1. So dou h by dou v into minus 1 plus dou h by dou w. Dou h by dou w we don't know. Now dou w by dou x. Dou w by dou x. This is our w. So dou w by dou x is 1. So this becomes dou h by dou u into 0 plus dou h by dou v into minus 1 plus dou h by dou w into 1, that is dou h by dou w minus dou h by dou v. Dou h by dou w minus dou h by dou v. That is our hx. Hx is dou h by dou w minus dou h by dou v. Now the second partial derivative, that is hy, that is dou h by dou y. Dou h by dou y, the formula is dou h by dou y equal to dou h by dou u into dou u by dou y plus dou h by dou v into dou v by dou y plus dou h by dou w into dou w by dou y. So dou h by dou u, we don't know the answer what is. Now dou u by dou y, dou u by dou y is 1. Dou u by dou y is 1. Dou h by dou v into dou v by dou y. Dou v by dou y is 0 because v does not contain the term y. So dou h by dou u into 1 plus dou h by dou v into 0 plus dou h by dou w into dou w by dou y. Dou w by dou y. Dou w by dou y is minus 1. So this becomes dou h by dou u minus dou h by dou w. Dou h by dou u minus dou h by dou w. So that is the expression for hy or dou h by dou y. One more term is there, hz. Hz. How can you find hz? Look at this diagram. Hz, dou h by dou z. Dou h by dou z is found out by dou h by dou u into dou u by dou z plus dou h by dou v into dou v by dou z plus dou h by dou w into dou w by dou z. So substituting those values in this expression, dou h by dou u into dou u by dou z, dou u by dou z is minus 1, plus dou h by dou v into dou v by dou z, dou v by dou z is 1, dou h by dou u into minus 1 plus dou h by dou v into 1 plus dou h by dou w into dou w by dou z, that is 0. Dou h by dou w into 0, that is 0. So you get dou h by dou v minus dou h by dou u, dou h by dou v minus dou h by dou u. So you have got hz also. Adding all these expressions, that is hx plus hy plus hz, this plus the third expression, this, you get hx plus hy plus hz equal to dou h by dou w minus dou h by dou v plus dou h by dou w minus dou h by dou w, this one, the second one, plus dou h by dou v minus dou h by dou u, the third one, this expression. Now dou h by dou w minus dou h by dou w becomes 0, minus dou h by dou v plus dou h by dou v becomes 0, and dou h by dou u minus dou h by dou u becomes 0. As a whole, this whole expression reduces to 0, that is hx plus hy plus hz equal to 0. So the only thing we have done is we have modified the given problem so that we can apply the chain rule. For that I have just substituted u equal to y minus z, v equal to z minus x, w equal to x minus y, and you get this scheme. H depends on u, v, w, u, v, w depends on x, y and z, so that you can apply the chain rule directly. So that is a simple problem. Now come to the third problem. Prove that x square wx plus y square wy plus z square wz equal to 0 if w equal to f of y minus x by xy, z minus x by xz. So this is my function w that depends on these two functions, w equal to f of y minus x by xy, z minus x by xz, and I have to prove that x square dou w by dou x plus y square dou w by dou y plus z square dou w by dou z equal to 0. Now we will find each of these derivatives one by one. Before that I have to convert the given problem so that some chain rule can be applied. Now how can you convert the given problem? As in this case, you have to substitute for these two functions. I am giving w equal to f of y minus x by xy, z minus x by xz equal to, I am splitting the this function, that is you get f of 1 by x minus 1 by y, 1 by x, you split the denominator or split the numerator, you get 1 by f of, this becomes 1 by x minus 1 by y, and this becomes 1 by x minus 1 by z. So the given function is f of 1 by x minus 1 by y, comma 1 by x minus 1 by z. I am substituting this as, or putting this as f of uv. Say f of uv, this function or this function equal to f of uv, where u equal to, so w equal to f of uv, where u equal to 1 by x minus 1 by y, v equal to 1 by x minus 1 by z. So our function has been reduced in the form w equal to f of uv, where u equal to 1 by x minus 1 by y, v equal to 1 by x minus 1 by z, and this will be our diagram. W depends on u and v depends on three variables. W depends on u and v depends on three variables x, y and z. So basically w contains three variables. What are the variables? X, variable y and variable z. So definitely we will have three partial derivatives, that is dou w by dou x, dou w by dou y and dou w by dou z. So first of all we have to find those three partial derivatives. Now come to the first one, wx means dou w, so we have to substitute those values in this expression and we have to verify whether the sum is 0 or not. Now wx is dou w by dou x. The formula for the chain rule for dou w by dou x by looking at the diagram is dou w by dou x equal to dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x, dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x. That is dou w by dou u, we don't know what is dou w by dou u, so keep it as such, dou w by dou u into dou u by dou x, dou u by dou x. What is our u? This is our u equal to 1 by x minus 1 by y. So dou u by dou x is differential of only 1 by x because 1 by y is a constant. So differentiating this with respect to x, you get minus 1 by x square. So dou w by dou u into minus 1 by x square plus dou w by dou v into dou v by dou x. Dou v by dou x is again v is 1 by x minus 1 by z. So the only function containing or the part containing x is 1 by x. This is a constant. So dou v by dou x is again minus 1 by x square. So you get dou wx or dou w by dou x equal to dou w by dou u into minus 1 by x square plus dou w by dou v into minus 1 by x square. Now I am finding x square wx, so that it will be easy when you substitute here. X square wx or x square into dou w by dou x. I am simply multiplying this quantity with x square. So when you multiply this with x square get cancelled. This also x square get cancelled. So x square wx equal to minus dou w by dou u plus minus dou w by dou v. X square wx equal to minus dou w by dou u plus minus dou w by dou v. This is our first expression. This term. Now the second one is, to find the second term you have to find wy. Wy from the scheme you get wy is dou w by dou y. Wy is dou w by dou y. Dou w by dou y is dou w by dou u into dou u by dou y plus dou w by dou v into dou v by dou y. Dou w by dou u into dou u by dou y plus dou w by dou v into dou v by dou y. Again, dou w by dou u, we cannot find what is dou w by dou u, but you can find dou u by dou y. Dou u by dou y is differential of this one with respect to y, that is simply 1 by y square. Actually the differential is minus 1 by y square, but here there is one more negative sign, so this becomes minus becomes positive. So dou w by dou y equal to dou w by dou u into 1 by y square plus dou w by dou v into dou v by dou y. V does not contain a term involving y, so dou v by dou y becomes 0. In effect, wy equal to dou w by dou u into 1 by y square. Only this term will remain. This becomes 0. Wy equal to dou w by dou u, or this is equal to dou w by dou u into 1 by y square. Dou w by dou u into 1 by y square. Now y square wy, this is second term. Wy is dou w by dou u into 1 by y square. Y square wy equal to, multiplying this quantity or this quantity with y square, you get simply dou w by dou u. So y square wy is dou w by dou u. X square wx is minus dou w by dou u plus minus dou w by dou v. Both of them we have found out. One more term is remaining, that is this one, z square wz. Now wz equal to dou w by dou z. Wz equal to dou w by dou z equal to dou w by dou u into dou u by dou z plus dou w by dou v into dou v by dou z. Wz equal to dou w by dou z equal to dou w by dou u into dou u by dou z plus dou w by dou v into dou v by dou z. Now this becomes dou w by dou u into dou u by dou z. U is this one. It has no z. So the differential is 0. So dou w by dou u into 0 plus dou w by dou v into dou v by dou z. Dou v by dou z is again 1 by z square, because here there is one minus. Differential of 1 by z is minus 1 by z square. So this becomes dou w by dou u into 0 plus dou w by dou v into 1 by z square. Or this reduces to dou w by dou v into 1 by z square. Simply dou w by dou v into 1 by z square. Now what happens when you multiply this quantity with z square into wz to get this one, z square into wz. Z square get cancelled and you simply get dou w by dou v. So z square into wz equal to dou w by dou. So we have obtained x square wx, y square wy and z square wz. Adding all these three terms, you get x square wx plus y square wy plus z square wz equal to minus dou w by dou u minus dou w by dou v, this one, plus dou w by dou u plus dou w by dou v. Minus, everything get cancelled, you get the answer as 0. So x square wx plus y square wy plus z square wz equal to 0. So we have proved or we have verified the statement. We will do one more problem in this video. So it's a simple problem. Look at this. Suppose w equal to x square plus y square. X equal to cos t plus sin t, y equal to cos t minus sin t. Find dw by dt. It's very clear. Clearly it is mentioned that we have to find the first the total derivative. So you can look at the function itself. W depends on x and y. X and y depends on the single variable t. So the scheme is like this: W, xy, and xy depends on t. So the expression for total derivative dw by dt equal to dou w by dou x into dx by dt plus dou w by dou y into dy by dt. Dou w by dw by dt equal to dou w by dou x into dx by dt plus dou w by dou y into dy by dt. Substituting these values, dou w by dou x is 2x. dx by dt is minus sin t plus cos t, or cos t minus sin t plus cos t. Its differential is minus sin t plus cos t. So I am writing it as cos t minus sin t. So 2x into cos t minus sin t plus 2y, that is dou w by dou y. Dou w by dou y is 2y. 2y into dy by dt. Dy by dt, what is dy by dt? That is minus sin t minus cos t, minus sin t minus cos t. So 2x into cos t minus sin t plus 2y into minus sin t minus cos t. Now you substitute the values of x and y in this expression. Substituting the value of x and y in this expression, you get 2 into x means cos t plus sin t into cos t minus sin t. 2 into cos t plus x is cos t plus sin t. So 2 into cos t plus sin t into cos t minus sin t. And taking this minus outside, so minus 2 into y is cos t minus sin t into sin t plus cos t. When we take this minus outside, you get minus 2 into y is cos t minus sin t. Y is cos t minus sin t into sin t plus cos t. This term becomes sin t plus cos t because I have taken this minus outside. So 2 into cos t plus sin t into cos t minus sin t minus 2 into cos t plus sin t into cos t minus sin t. Both of these terms are one and the same. These and this. So minus means the effective sum will be 0. So dw by dt equal to 0. Again, there is another method you can find by substituting x equal to cos t plus sin t and y equal to cos t minus sin t in this expression. You can differentiate it. Obviously, you should get the value 0 itself. Both of these values should be the same. So we have discussed some 4 problems which relates to different chain rules. Sometimes I will be stopping here. Most probably if I get some more problems, I will include it in another video. But I don't think that is a necessity because all these are just by hearting the formula and simplifying it. So always I simplify, that is of no use. The only thing that you can do is you refer the books, do as much as problems you can, so that you will be thorough with these operations. Otherwise you will make some careless mistakes or something like, because one single change in the plus or minus sign may depends or we will change the answer. So I am stopping here. Further problems I think I will not be doing. I will be just switching over to the next topic in the coming videos. So I am stopping here. See you in the next video.